Good evening everyone, I am S. Lokeshwaran, Assistant Professor, Department of Civil Engineering, KPR Institute of Engineering and Technology, Coimbatore. In this video, we are going to see the topic under Airport Engineering, problems on basic runway length. Okay, so before entering into the concept, we need to remember certain points. So that is nothing but correction for elevation, temperature and gradient. We need to implement these corrections to determine the actual length of the runway from the basic runway length. Okay, so let us see one by one. First one, correction for elevation. So increase in length is equal to 7% for every 300 meter elevation. So correction for temperature is equal to 1% for every 1 degree rise of airport reference temperature above standard atmospheric temperature at that elevation point. Third one, correction for gradient. So increase in length is equal to 20% for every 1% effective gradient. So these 3 points are very important while solving the problem, and it may vary. Sometimes we need to provide correction for elevation alone or temperature and gradient. It depends upon the problem statement. So before entering into the problem statement, we need to know the formula for calculating the airport reference temperature. So ART is the short form of airport reference temperature, that is equal to TA plus Tm minus TA divided by 3. Tm is equal to maximum daily temperature. TA is equal to average daily temperature. It is the mean value of maximum daily and maximum average daily temperature. So let us see the problem statement. Monthly mean of average daily temperature of the hottest month of the year at an airport site is 40 degrees Celsius. Monthly mean of maximum daily temperature for the same month of the year is 50 degrees Celsius. Calculate the airport reference temperature. They are asking the ARP if the site is at mean sea level with a level ground. So there is no elevation. We need to determine the actual length of the runway to be provided. Here they have not mentioned anything about the length of the runway, that is basic length of the runway. So we can keep the length of the runway as L. Solution: mean of maximum daily temperature, that is Tm is equal to 50 degrees Celsius. Mean of average daily temperature, Ta is equal to 40 degrees Celsius. So airport reference temperature ART is equal to Ta plus Tm minus Ta divided by 3. So Ta is equal to 40 and Tm is equal to 50. 50 minus 40 divided by 3. Finally we got the value as 43.33 degrees Celsius. So we know that standard atmospheric pressure at mean sea level is equal to 15 degrees Celsius. So we need to calculate the rise in temperature from the normal value. Rise in temperature is equal to 43.33 minus 15, that is equal to 28.33 degrees Celsius. So the rise in temperature is equal to 28.33 degrees Celsius. And we have to make correction for change in temperature. So here 1% as per the condition, 1% per 1 degree Celsius we need to provide. So basic runway length, as I said earlier, like we considered as L meters. Required correction is equal to 1 by 100, that is 1% 1 by 100 into L into 28.33. So L by 100 into 28.33 is equal to 0.2833 into L meters. So corrected length from the basic runway length is equal to L plus 0.2833 L. So that is 1.2833 L meters. So conclusion, therefore the actual length of the runway to be provided is equal to 1.2833 times the basic runway length. So this is very important. While suppose in the same problem, if they are asking about the length for 1.2 kilometers, if they have mentioned, you can multiply with the values. Okay, here they have considered only the length of the kilometer and we can keep the L as it is. Thank you.